Hi, in this section we're going to talk about electric current. We are going to discuss atoms and electrons. We're going to define what is an electric current, and we're going to talk about the current direction convention. Electric current is simply the rate of flow of electric charge. Let's look at the example here to the right. Let's say you have an electrical wire, so like a piece of copper, for example. So we are looking at a section of the wire. The wire actually continues here and there. So it's just a little section of it. And let's say you have 3 electrons on the left side. And you are an observer. You are somewhere in the middle of the wire, and you just monitor a certain section of this wire. You just look at a particular section. Now, I could ask you to do a certain experiment, which is in a certain amount of time, delta t. You can choose the amount of time. It could be 1 second, 1 hour, 1 year. It could be 1 microsecond. It could be as long or as short as you want. You will just be sitting there and count the number of electrons that pass from left to right. At the end of the experiment, you will have a certain number of electrons here, and E. And if you multiply the electron by E, which is the charge of 1 electron, you basically know what is the total amount of charge that passed. If you divide the total amount of charge that passed, which I'm writing as Q here, by delta T, what you get is the electric current. Electric current is the amount of charge that passed during a certain time along a wire. The unit of measurement of the electric current, the natural unit of measurement, will be Coulomb divided by second, because we have charge divided by time. But because the current is such an important thing, it has its own unit of measurement that is called ampere, and it's indicated with A. So you can see here I substitute Coulomb divided by second with A. There is a very important thing to remember, which is the convention of the direction of the current. The general convention is to have the direction of the current to be the same as the direction of movement of positive charges. What does it mean? Given that usually in electric circuits and wire, what moves are really electrons, and electrons have a negative charge, the direction of the current is the opposite of the movement of the electrons. So in this case, that will not be the right direction. Let me cancel it. But the direction of the current that you measure will be the opposite. It will be in this direction, so from right to left. Matter is made of atoms. We are made of atoms. Everything we touch is made of atoms. The reason why I'm bringing up atoms now, it's because I want to introduce the electron, which will be required to explain the electric current. On the right, I try to represent the structure of the atoms. There is a central part, which is the nucleus, which is made up of protons and neutrons. And then we have a third type of particle, which is the electron, that is floating around the nucleus. You can see here there is like a cloud of electrons around the nucleus. Protons have a positive charge of value E. E has a certain value that we'll describe later, while electrons have a negative charge of value minus E. Neutrons have no charge. E is equal to 1.6 multiplied by 10 to the power of minus 19 Coulomb, where Coulomb is the unit of measurement of the charge. Atoms are usually neutral, which means that they have the same number of electrons and protons.